Good evening, students. So today let us discuss about resonating structures. Okay, so how we can write the resonating structures? So here to write the resonating structures, so we need to remember 2 points. First point is how these charges are rotating on the molecule. So first point is we can write lone pair or negative charge. So actually this is lone pair converts into bond pair. Okay, so next multiple bond. Okay, so multiple bond convert into single bond. Okay, so like here one more point, like multiple bond. So if it is a double bond, it will convert into a single bond. If it is triple bond, it will convert into a double bond. So now look here, so this is the double bond, so we have break the double bond so that we will get positive and negative. So now this is a lone pair or negative charge. So here negative we have written, means how many electrons are there here? 2 electrons are there. Okay, 2 electrons are there. So now lone pair to bond pair means it will form the bond here. Okay, so it will form the bond here. And next this double bond will become a single bond, means double bond containing how many electrons? Double bond contains 2 electrons. So just these 2 electrons will shift onto this carbon and becomes the negative charge. Done. So this is the lone pair, so that is converting into double bond here. Done. And next that negative charge, it is converting into, negative charge is converting into a double bond, and this double bond is converting into a single bond. So like the same here, lone pair to bond pair, so this multiple bond will form the negative charge here, and this lone pair is forming the double bond here. Okay, next, so like the same again, same step will repeat. So this is the negative charge will become double bond here. Okay, so here positive charge also will be removed, as these electrons shared in between these two carbons, that positive charge also will be removed. So the first point is lone pair to bond pair, and next multiple bond to single bond. So in this case multiple bond to single bond, double bond convert into single bond and triple bond converts into a double bond. So let us write some other examples so that you will get some clear idea. So here what I am writing, CH2, so negative charge I have taken. Okay, benzene ring here. Done. So what is the first point? Negative charge or lone pair to bond pair. Multiple bond will break down and give a negative charge so that it will become a single bond. Okay, lone pair to bond pair, CH2, and here there was a double bond earlier, it breakdowns to give a negative charge here. And next again same process, negative charge bond, it will form the bond, this multiple bond will form the negative charge here, so that multiple bond will become a single bond there, double bond will become a single bond. So bond here, negative charge here, so here one double bond. And next one more resonating structures I can write, lone pair to bond pair, multiple bond to single bond. Okay, CH2. Okay, so here we are having the negative charge. Done. Here double bond. So now look here, so one more resonating structure I can write, lone pair to bond pair, so this multiple bond will form negative charge on carbon. Okay, double bond, so here double bond. So let us write one more example. So CH2 here we have taken negative. So here CH2 we are having negative. So now let us take positive ones. What happens? Let us take positive CH2 positive. Okay, double bond, double bond, double bond. Now try to understand the environment of this carbon. I am writing here. So one side hydrogen, another side hydrogen, another side it is attached to benzene ring. So now here we are having positive charge. So what is the hybridization of this carbon? The hybridization of this carbon is sp2. It is planar carbon, right? So now carbon generally it should have 4 bonds, but now it is having only 3 bonds. So this is having one vacant orbit. Okay, it is having one vacant orbit. Means vacant orbit means there are no electrons in that vacant orbit. So that is why, so as it is electron deficient now, this carbon is what? Electron deficient carbon. So as it is electron deficient, it needs electrons. As it is having positive charge, carbon should have 4 bonds. So it is having only 3 bonds, means it is electron deficient. It needs carbon, it needs electrons. So these electrons will be provided by this benzene ring. Pi electrons on benzene ring that moves towards this positive charged carbon. So first of all I am breaking this pi bond into a negative and a positive. Okay, positive charge on benzene ring. So this negative I am writing little bit sidewise. Okay, CH2 plus. Okay, just I have broken down this double bond. Okay, I got negative and positive. So now this negative and this positive charge on carbon makes bond. So let us write that. So here bond has been formed, CH2. So here positive charge on benzene ring. Now here we have got positive charge on benzene ring. So in earlier examples what we got? Negative charge on benzene ring. And even first example what we got? So here we are having both positive and negative, that is okay. Okay, here what we are getting? Negative charge on benzene ring. So here what we are getting? Positive charge on benzene ring. So now this positive charge will resonate, undergo resonance. So positive charge, look at this bond. So always, so just remember one simple trick here, 1, 2, 3. I have given numbering. So one number to the positive charge, second number, third number. So directly this positive charge will shift on to third carbon. So directly I can write the positive charge will shift on to third carbon. Okay. So in between 1 and 2 we will get the double bond. That's it. Write one more structure here. So here I am writing. So 1, 2, 3. Where the positive charge will go? To the third carbon. What happens in between this 1 and 2? It will form the double bond. Okay. So now where this positive charge will go? 1, 2, 3. Third carbon is CH2 carbon. So this positive charge will go on to CH2. So where the double bond will form? In between 1 and 2. Okay. So this structure and this structure both are same. Okay, so these are some of the examples like how we can write the resonating structures. So hope you understood how we can write the resonating structures. So now for example here I have written CH2 plus single bond C double bond C. Okay. So now what are the resonating structures? Try once. First carbon, second carbon, third carbon. Where that positive charge will go to? Third carbon. Just I am writing here. So where the double bond will form? In between 1 and 2, here you form the double bond. Now here you can understand positive charge is going on to the third carbon. So earlier there is a double bond here. Now what we are having? Single bond. So that is what we said. Multiple bond will become the single bond. So how many resonating structures we are having here? two resonating structures. Like the same, try once, negative charge CH, double bond CH2. Now try to write the resonating structure, one number to the carbon which is having negative charge or positive charge. So this negative charge will shift on to the third carbon. Okay, so this double bond here, double bond here, it will become single bond. So where we will form the double bond in between 1 and 2 carbon. Done. So actually what happens here, this negative charge will shift here and this double bond will shift on to the carbon. So that is what happens. So two resonating structures we got. Try this once. NH2 CH double bond CH2, lone pair, bond pair, multiple bond to single bond, then H2 double bond CH single bond CH2 minus. So now what should be the charge on this nitrogen, positive or negative? Think once. Nitrogen, one side one hydrogen, two hydrogens are there, double bond with carbon. Nitrogen can form only 3 bonds, here it is forming 4 bonds, so that is why here positive charge you will get on the nitrogen. Okay, done. So that is how we will write the resonating structures. So hope you understand. We will meet again in the next class. Till then, bye, take care.